Now, the Jacobian also can be written in form as dou A by dou x at constant b, dou A by dou I at constant b, dou B by dou x at constant a, dou B by dou I at constant a. This is a determinant form. So, I have given the integral form also for you. It's a cyclic integral of a dv by cyclic integral of x dy. What is the meaning of cyclic integral? You start at a point and come back to the same point. It's called cyclic process. So cyclic integral is the area under this curve. Okay. Therefore, you plot A versus B. A versus B. Suppose you get an area like this. Then this area is called the cyclic integral AdB. Similarly, xy you plot. You got an area like this. Then this area is your cyclic integral x dy. So area of in the AB plane divided by the area of the xy plane is called Jacobian. Now, since Jacobians are related to matrices, all the properties of matrix are applicable to Jacobians. First property, property 1. 1. Jacobian AA equal to 0. And second property is Jacobian AB equal to minus BA. See, you put AA in the determinant, say it will be the determinant becomes 0. Similarly, if you AB equal to minus BA, change rows into columns and columns into rows, then it will be a negative sign. Third Jacobian is, suppose you have got dou A by dou x at constant B, you can write this as A comma B divided by x comma b. Dou A by dou x by constant b is a comma b by x comma b. For example, so we got dou t by dou p at constant v. We can write this as, you apply this, you can write tv divided by pv. The square bracket represents Jacobian. And the last Jacobian is property is, suppose dz is equal to m dx plus n dy, okay, then zx is equal to the capital X, mind you, m xx plus n yx. For example, I will give you an example. There are 4 properties which you have to remember. For example, we know enthalpy. Remember, AF HE VTPS. Now we know yesterday that dH is equal to VdP plus TdS. VdP plus TdS. dH is equal to V into dP, T into ds. Okay. Now, suppose the capital X is the temperature, then I can write HT equal to V PT plus T ST. Okay. I can also suppose X is equal to P, then I can write HP equal to V PP plus TSP. Now look at one of the properties of Jacobian. Jacobian AA equal to 0. Remember, that means this term will become 0. Therefore, HP will be equal to TSP. Now look at another property. If you look at other property, I have given you another property. Dou A by dou B at constant x is equal to ax by bx. Okay. Now use this property and write this as, you can write this as what? Hp by Sp equal to T. Bring down this here, or apply this law, you will get dou H by dou S at constant P equal to T. See how easy it is. I converted, use this relation and convert this. Okay. Now I will show you that all the four Maxwell's relations give the same result. Look at the Maxwell's relations I given yesterday. V, T, P, S. Okay, let's take this Maxwell relation. Dou S by dou V at constant T. Dou S by dou V at constant T is equal to dou P by dou T at constant V. Dou P by dou T at constant V. Okay, now I can write this using Jacobian. Say ST by VT. ST by VT equal to PV by TV. TV by PV. Now I can write this as minus TV. Okay, this is because Jacobian AB equal to minus BA. Okay, I can apply this formula here. Jacobian PV by minus VT. Now this VT will get cancelled. You will get ST equal to minus PV. Or I can change this to minus. Therefore, TS minus equal to minus PV. That is, cancel the minus sign. You will get TS equal to PV. Now, this one Jacobian. The other three more Jacobians, you show that other three Jacobians also gives a result TS equal to PV. Or other Jacobians also give same result. So all four Jacobians, four Maxwell's relations will give the same result TS equal to PV. What does it mean TS equal to PV? TS by PV equal to cyclic integral of TdS by cyclic integral of P dV. What is TdS after all? You remember dq equal to TdS, remember, and dw equal to P dV. So what is cyclic integral? You plot P versus V, you get some area. Plot T versus S, you get some area. Now what does this say? TS equal to PV equal to 1. That means area on the ST plane and area on the PV plane are same. That means, that's what it means. That means physically this area is nothing but, if you integrate this you will get Q. So this is Q, this is W. This area is Q, this area is W. That means it says that in a cyclic process Q equal to W. This is obvious because we know delta E equal to Q minus W. In a cyclic process, start and come back to the same point, delta E will be equal to 0. Therefore, Q will be equal to W. Therefore, the ultimate, what does the Maxwell rate tell us? Maxwell rate tells us that heat effect is equal to work effect in a cyclic process. That's what it says. So, all Maxwell's relation gives the result that heat effects equal to work effect in a cyclic process. This is because of TS equal to PV. See, this kind of relations you can't get directly unless you convert this Jacobian into, unless you convert your Maxwell's relation in the form ds by dt, etc. Convert to a Jacobian, we say that all the Maxwell's give the same result, TS equal to PV. Okay? Now, I'll give one or two problems you can try. You take H as a function of T and P. Then you can write dH as equal to dou H by dou T at constant P dt plus dou H by dou P at constant T dP. So this you know, H is the function of T and P, dou H by dou T at constant P equal to T plus dt, dou H by dou P at constant equal to D into dP. Now, you can apply the law. dou H by dou T at constant P is equal to HP by Dp. Similarly, dou H by dou P at constant T, dou H by dou P at constant T equal to HT by Pt. So this you can write as this one, and this you can write as this one. Now let me define a few terms. Specifically, at constant pressure is T dou S by dou P at constant T, or that is equal to T St by Pt. Similarly, Cv equal to T dou S by dou V at constant T, or T St by Vt. Then we have got volume coefficient of expansion alpha. Alpha as alpha T, volume coefficient of expansion, minus dou V by dou T at constant P to 1 by V. Okay. Now, then isobaric pressure coefficient is 1 by P dou V by dou P at constant T. Okay, these are the four coefficients. Now, based on this, you can do so many wonders. Okay, you can do all of calculations. Now, for example, dH equal to dE. Just a minute.